Architeuthis.
Hi, I'm Guy Cope with Architeuthis, and welcome to Machine Learning Mondays, the series where I try to explain basic machine learning topics and knock the edge off some of the buzzwords out there. My goal is to make machine learning accessible to everyone, including folks who are not technically inclined. Today's topic, we're going to talk about the big one. What is machine learning, anyway? In traditional computing, a software developer writes code that tells the computer what to do, called a program. The computer interprets the code, follows the rules as written, and does exactly what the program tells it to do. Machine learning goes a step beyond. Rather than writing code to make a computer do something specific, the human who creates it uses data and algorithms to make the machine more accurate at predicting outcomes without being explicitly told to do so. Essentially, a way to make the computer work without telling it specifically what to do. That can be a bit of a complicated concept, so let's break this down and apply it to the financial crime space. Most transaction monitoring systems, and all of the early ones, have rules. And these rules can range from the simple, find transactions over $10,000 in a certain period, to the very complex, find all customers who have more than 3,000 miles distance from the previous transaction, with more than 2 transactions over $50 in the last 2 hours. No matter what, however, the system will produce an alert for a compliance officer or someone to work that meets the criteria of the rule. In the example of the $10,000 rule, in this case, it will take a look at your entire customer base, take a look at a time period set by you or the programmer, let's say 2 days for the weekend or a 24-hour period for a week, similar to a CTR rule, and then it will find every single customer that had a cash transaction over $10,000. And it may very well be alerting on any transaction that appears to be cash. So the outcome is simple. If you have a customer that had a $10,000 cash transaction or greater in the period of time specified, an alert will be raised. The compliance officer will go in, work the alert, and then clear it. Maybe it's true positive, maybe it's a false positive. And then next week, that alert might show up again. And every single time that customer makes that transaction, whether you need to know about it or not. That's because the system is doing precisely what it was told to do. In the case of the more complex geolocation rule, we do have to take a look at some other factors. The big factor is distance. One transaction took place where the customer lives on the East Coast, and the other took place on the other side of the country very quickly. There may be all kinds of factors involved here, including the speed of the transaction and the amount, but the key is that the system is going to do what you've told it to do. So no matter how many factors you put in, so long as you meet the factors, an alert will be generated. And if you want to make this rule more effective or have other factors in it, you will have to either manually add them to the rule yourself, or you'll have to have your technology vendor add them to your rule. Meaning that if you want to change it, you're going to have to do a lot of manual analysis and do a lot of digging into the data just to completely understand why the rule is triggering. Either way, every single transaction that meets that criteria, whether it's one you want to look at or not, will trigger because that's what the rule tells the system to do. In machine learning, you might start with a rule in order to target the data you find most important, but it won't end there. Most transaction monitoring systems employ machine learning using a technique called supervised learning. In supervised learning, the machine learning model uses what's known as training data and define variables called product features to produce alerts. Let's dig into what those mean by using an example of an alert that might generate using a machine learning model. Let's say an alert is produced on Jane Happenstance. Miss Happenstance has a transaction that occurred in Los Angeles at the same time a transaction on the same card occurred in Atlanta. A compliance officer will open the alert to review, and it appears that the transaction was not actually that far apart, but was in fact an online web store that processes their transactions in Los Angeles. So the compliance officer will then go in and mark that alert as a false positive. But that isn't the end of the story. Unlike with a rule, the machine learning model will take the decision made by the compliance officer to train itself on new information. And that information might be, yes, it was far apart, yes, it's on the same card, but it doesn't appear there was any travel. Both transactions occurred from an IP or a geographic location in the same area, and that it was an online store. The model will then use that training data, those decisions, to make the variables involved more important, which will help suppress the alert in the future. And if all that seems complicated, the way to think about it is this. You're training your system using machine learning to come to the same result that the compliance officer would have come to without actually needing the compliance officer's involvement. So you don't need to go in and add new variables to the rule or modify anything. The machine learning model will do that for you. Essentially, the model is going to imitate the human or humans who train it. What that means from a practical standpoint is that as these other alerts start popping up that have these exact same factors, the system will use these underlying factors you may not have considered until you looked at the alert to come to the correct decision ahead of time. And that's going to make the system work better and better as you work on it. So the longer you invest, the more time you invest into the machine learning model, the better it will work over time. Now, is it possible for the machine learning model to come to conclusions you don't want it to? It is. And we're going to talk a little bit about that when we talk about the other types of machine learning in next week's Machine Learning Monday. So let's review. With a supervised machine learning model, the people who use the model will make decisions. Those decisions will then train the model, and the model will then produce alerts and make decisions more like the people who use it, all without having to make any changes to the rule or doing any new programming. And there's a lot more out there in machine learning, other techniques, other models that are used, and more detail for supervised learning. And I could make this video be hours long. But instead, as I said earlier, we're going to cover all those other machine learning techniques as we go through in future videos. Next week, we're going to talk a little bit about the 4 major types of machine learning that are used in this space and talk a little bit about why some are favored over others. So if you enjoyed this video, please like it, leave a comment, and subscribe to the channel. Thanks everyone so much for watching, and remember, if you have machine learning questions, and I suspect you do, Architeuthis has you covered.
Thank you for watching. Please like, subscribe, and leave a comment.